So before the break, the limits that we learned is to help us to understand what happens near asymptotes, right? Around like goes to infinity, right? Or on the left side or right side of vertical asymptote. Okay, so the next part is to apply limits to talk about graph as well. But this time we'll be checking whether at a place if it's continuous or not, right? Continuous means there's no broken place like empty dots, right? Or if there's an asymptote, right? So usually the parts that we want to check is for piecewise function. We want to see if the pieces are connected nicely or not, okay? So that's called continuous function, right? So the next part is using limit to check if the function is continuous or not, okay? Before the break is to check near the asymptote, okay? So make sure you distinguish these two goals, right? So the next part, let's look at here. For continuous, there are also two kinds. One is to check if it's continuous at a single point. Okay, so you can circle that at a point. Okay. And then after that, we'll be learning how to check if it's continuous for the whole function. Okay, so number two, property of continuous function. So basically, if they are if they belong to continuous function, you don't need to check because they are guaranteed to be continuous. Okay, so usually we just need to check if they are piecewise, and then make sure the pieces are glued together. Okay, so let's look at an example so you can understand what we are talking about here. So first part, we'll be checking continuous at a point, right? So maybe you can learn something from the definition here, okay? So because by now you are very familiar with the symbols now. Okay, so the first part we have x approaching A. So A is the point that we want to check, okay? So approaching A from the left, and then approaching A from the right, and then f of A. If the three things, they equals each other. So, and all of the following conditions are true. So the first condition is f of A is defined. So meaning there's a point there, okay? If you're subbing, for example, if you're subbing 5, you get a number out, right? Then you call that as defined, right? If you sub it in, you get like undefined. Undefined means denominator will be 0, right? Then it's undefined. Second part, limit exists. Okay, limit exists means the left limit should equal to the right limit. Okay, and then limit exists and also equals to the point. Okay, f of a f of a is defined, so this has a point. Okay, has point. So basically, you combine the number 1 and number 2 together, you get number 3. Number 3 is saying left limit equal to right limit, and then equals to the point. Then we will say the function is continuous at that point. Okay, we'll look at just first definition first, okay? So let's look at an example, right? For the given graph, determine the interval where the function is continuous. So this one, if you have a picture, it's very clear which part is continuous, which part is broken, right? Basically, if you need to lift up your pencil to continue the graph, that means it's broken, right? If you finish the graph without lifting, then it's continuous, right? So we go from left to right. So for example, here I'm using the arrow, okay? You see the blue arrow, right? I keep on going from the left side. So everything here is continuous, right? There's no dot. But once it goes to this point, empty dot, I need to lift my pencil and then move down to the bottom to continue. So there is a broken place. So the first interval that is continuous, okay? The question A is asking us to find the interval where it's continuous, right? So we'll say f of x is continuous on, okay, the first interval is all the way from the left end. So we'll do negative infinity up to the point. So interval is always x value, okay? You can write that down. Interval is x values. So negative infinity all the way to -3, right? The x is -3 there. So that's our first interval. We are using the interval notation, okay? Round bracket means it doesn't equal to it, okay? Or, right, this U shape means or, so the next interval starts from here, right? It'll be continuous until here, right? There's an empty dot. So that will be the second interval. So what should we write for the second interval? From where to where? Joan, can you try it?
Negative infinity minus and then -1.
Okay, the -1, you got it right, okay? Because negative infinity, we already included in the first graph, right?
Right.
You just focus on the second graph. The second graph starts from the very bottom, right? And the very bottom is very close to -3. So you just say -3 to -1.
Okay.
Okay, so that describes where the second piece starts and ends. Okay, or let's keep walking. Okay, so we start from here, right? I need to lift up the pencil, jump the hole, right? And then continue the graph, right? So keep on going. All these are continuous, right? So that will be the third piece, okay? What will be the interval for the third piece? Nicole, can you try that one?
Maybe positive infinity.
We are only looking at x values, okay? Focus on x values.
2.
2, yeah, 2 is the right end, okay? How about the left end? I'll use the red color, okay? The third piece is starting from here. Take a look, the red, right? Starting from here, and then keep on going to the right side, right? Towards 2. I'm talking about x values. So where is the starting of the arrow? The red one.
-1.
Yes, okay? You get it now? Right, you just look at the x value of the left end and the right end of the graph, okay? Where it's close to. So, and because it's round circle, right? Round bracket, so that means it's not including -1, okay? Means greater than -1. All right, so let's keep going, okay? Or now the next piece, I'm going to use green, right? I need to lift my pencil up and move down to here, down here, and then continue the graph. So the second piece will start from the bottom and then keep on going up, 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 right? And then there's an empty circle, so I stop. Okay, so what will be the second in the next interval? Leon? From
Be 2 and 1.
2 and where?
2, 1.
You need to focus on the x values.
Oh, right. 2, 5, I think.
Yes, yeah, okay. So it's for 2 to 5. Right? Empty circle means it doesn't reach 5. Right? Everything before 5 and then after 2, right? 2 is right here. So the graph is between 2 and 5. All right. Now we have next color. Okay, I'm gonna use blue again. So start from this time, it doesn't have empty circle, right? So that means it's including 5, and then keep on going up, and then it will continue, right? There's no broken. and keep on going forever, right? So what will be the last interval? Emily, can you try this one?
Would it be positive infinity?
Positive infinity will be the right end, right?
Yeah.
How about left end?
5.
Yes. And because it includes 5, so we need to use what kind of bracket?
Square brackets?
Yeah, so you need to put square. That square is equal, okay? So for example, right, like this one, for this interval here is the same as saying x between -1 and 1, right? It's a shorter way to write it. For this one is saying x is bigger or equal to 5, right? So it's just using interval notation is more convenient to write, right? You don't need to write a lot of inequality signs. Any question about how we get this? Okay, because you need to do the interval for your homework, okay? Make sure you understand how to write out the interval. Always go from left to right, one by one. Any questions? Okay, now the next part, so this is for part A, right? Part A is to write out the intervals of continuous part, right? Part B is we are going to find all the points where the function is discontinuous. Okay, so we want to find out where it's discontinuous. So when it says all the points, you just answer the x value of the point. Okay, so you can say f of x is discontinuous at, okay, we have couple points, right? Where is the first x value that's discontinuous? Jesse?
The first I got was it's discontinuous at x equals to -3.
Yeah, very good. Okay, so that's where it's broken, right? What's the next one, Joan?
X equals -1.
Yeah, okay, Carrie, next one.
X equals to 5.
Okay, oops, x equal to 5. Okay, and Leon, next one.
2.
Yeah, right, as long as you need to lift the pencil, then it's broken, right? Then it's called discontinuous. All right. Now for different places, we have different kinds of discontinuity. So different types. Okay, so here we want to describe each discontinuity as jump, removable, or infinite. Okay, and then we also need to talk about continuous from the left or continuous from the right side. Okay, so we'll mention about this one. This one is a special one. Okay, we'll leave that later. So right now, discontinuous. Yeah, I spelled it wrong. No wonder it looked weird. Okay. Okay, so the first type is called a jump. Okay, let's list them out, and then we have the removable, and then we have the infinite. Okay, 3 kinds of discontinuity, different types. So jump means you have to jump over, right? Okay, so basically you need to lift your pencil, right, and then make a bigger gap rather than just a little dot, right? So for example, the one at 5, that will be called jump, right? From the green one, jump to the blue one. So here's the jump, right? You see I use the red, okay? So this one jumps to here, right? From the empty dot, jump to the blue dot, and then you continue, okay? So that will be called a jump. So x equal to 5, okay? And then the removable means we can remove, okay? Able to remove, right? That's why the name, removable. So able to remove the discontinuity. Okay, meaning you are able to make it continuous. For example, like the jump, okay? If I want to make it continuous, okay, let me zoom in, right? If I want to make it continuous, I can do this, right? I can draw this and then connect, right? But then if you do it like that, it won't be a function anymore, right? Because for it to be a function, every x can only have one y, right? So you cannot make it continuous, okay? And then same thing here, because of asymptote, right? This one you cannot just draw a line, right? What it means by able to remove discontinuity is just by adding a point. If you are able to just adding one point and make it continuous, then you call that removable. Okay, so the only place that could happen is at -1. Okay, so let me use the green one at x equal -1, because I can just fill in this dot, very easy to remove, right? Then we got rid of the discontinuous. We made it into continuous. Any questions so far? Okay, so able to remove the discontinuity at x equal -1 by adding f of x equal to, by adding f of -1 equals to 0, right? By defining and x equal to -1, it has to equal to 0. So I'm actually adding in a point, okay? Then it becomes continuous. Okay, so that's called removable discontinuity. It's a discontinuity that can be removed. All right. The last one is the most obvious one. Okay, any place that has asymptotes, okay, infinite, then we call that infinite discontinuity. So for example, we get asymptote at -3, right? So x equal to -3, right? Where is the other one? Jesse?
X equals to 2.
Yeah, okay, you get another infinity. Okay, so that took care of all the discontinuity place, right? 5 is jump, right? -1 is removable, right? -3 and 2, they are infinite. Okay, so the last thing is talking about continuous from the left or continuous from the right side. So we need to look at the second box. So go to the top, right? So I need you to group these two together. So if the left limit equals to the point, then we say it's continuous from the left, right? Left limit, okay? Next part is if the right limit equals to the point, then it's called continuous from the right. Okay, so let's think about the first box first, okay? So for example, let me erase the green dot first. I want you to focus on this one. Okay, I erased the green dots, right? So let's check the limit, okay? Let's just do some review, right? Don't forget you're in the beginning of the term, right? We learned some limits. Limit as x approaching, let's say, -1 from the left. Okay, what's the answer for this one? X approaching -1 from the left. Leon?
Negative infinite.
Okay. Okay, let me erase the arrows first, okay? Okay, x approaching -1, so you have to look at -1, right? -1 is here, and coming towards -1 from the left side, like that. Do you see it, Leon?
Mm-hmm.
Okay, so where is the arrow heading towards?
-1.
X is approaching -1, but when we find limit, we're looking for y values.
Oh, it's heading towards 0.
Yes, okay, so the answer for the left limit, it equals to 0. Make sense?
Yeah.
Yeah, okay. Now can you try again? For limit, also approaching -1, but from the right side. What's the answer?
Then also 0.
Also 0, very good. Okay, so it will be going down towards here. So now here we have left limit equals to the right limit. What does that tell us when we have left limit equal to right limit? Joan, do you remember? After we check left side equals to the right side, what does that mean?
It means that the limit of f of x exists.
Yes, okay, so this tells us limit of x approaching -1 of the function. It has a limit which equal to 0. The limit exists. Does that guarantee it's continuous there? Carrie?
Um, yes.
If the
there's-
limit are equal each other, does that mean it will be continuous at that point as well?
Yes.
Well, right now, do they equal each
Yeah.
other?
Yeah, they do.
Is it continuous there?
But it's not continuous there.
Yes, okay. So even if the limits they equal, it doesn't necessarily mean it's continuous there, right? So that's why at the very top, we have left limit equal to right limit, but we need to add one more condition. It must also equal to the point, okay, to make sure it's continuous. So if I try to find f of -1, okay, what is the answer for f of -1, Emily?
It doesn't. It's not defined.
Yeah, undefined, right? So therefore, it's not continuous there, right? Even though left and right are equal each other, but then there is no point there to fill the dot. So you will say not continuous, okay? So that's why we need 3 conditions, right? If the point is filled in, then f of -1 will also equal to 0. Then you will say it's continuous there. So you always need to check 3 things: left, right, and the point. Okay, so let's fill that in on the top. Left equal to right equal to point. Okay, so this part I need everyone to turn on your mic, okay, because it's very important. We need to repeat this together. Okay, everybody, please turn on your mic. Okay, so let's say it together: continuous at a point.
Continuous
At
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 a
the
point.
point.
Yes, okay, one more time: continuous at a point.
Continuous at a point.
At the point.
Left equal to right equal to point.
Left equals to
equals
right
to right
equals
equals
to
to
point.
point.
Okay. Left limit equal to right limit equal to f of a.
Left
Left
limit
limit equals
equals
to
to
right
right
limit
limit
equals
equals
to
to
f of
f of
a.
a.
Yeah, very good. Okay, so at your own time, you repeat a couple more times. Okay, this part, okay, will help us do many questions later. Okay, to check left, right, and the point. Now the second thing I want to go over is the continuous from one side. Okay, so this part is called continuous from one side. Okay, you can either continuous from the left or continuous from the right. Okay, so this one, I don't have any more space. Let's draw a line here. Okay, so for example here, I want to check at 5, okay? Let me erase the arrows for the 5 first. Okay, so it's all clear now, right? So let's do the left limit first. Limit x approaching 5 from the right side, okay? And then limit x approaching 5 from the left side. Oh, right side and left side. Sorry, I want to do left first. Okay, let's go from left. Approaching 5 from the left, approaching 5 from the right. Okay, and then we also want to check the point at 5. Okay, so let's start with the left limit. Approaching 5 from the left. Nicole, what's the answer for that one?
It's 1.
1, very good. Okay, the arrow will be looking like this, approaching 5, right? So going up, and then the y value is very close to 1. Okay, now approaching 5 from the right side. Lex?
It equals to negative
Negative what?
1.
1. Okay, very good. Okay, so the arrow will look like this. Approaching 5 from the right side will go up and then go down towards -1. Okay, now the next one is finding the point. F of 5. Leon, what's f of 5?
Would it be does not exist?
Well, this one it actually exists because the empty circle only happened at one place.
Oh, so -1.
Yes, okay, the point is at the bottom, right? So from these 3 parts, we have the right limit, right? And the point equal each other, right? Coming from the right, you are able to step on the point. So for this case, we will say it's continuous from the which side? Carrie?
Right side.
Yeah, okay, so this one is continuous from the right side, okay? Because coming from the right, you won't fall into a hole, right? You'll be safely stopping. Make sense? But if you're coming from the left side, you can only keep on going, but you will never stop at the point because it has an empty space. You can never keep, you will just keep on moving forward, but you never stop, right? Keep approaching. But for the right side, you will be stopping at a single point. Okay, so we call that continuous from the right. So easy way to remember is if you reach to a point, then it's called continuous, right? If there's a point, then it's safe. Okay, so for this graph, you only have that one. Okay, so similar for continuous from the left, you check if there's a point if you walk from the left side. Okay, so let's look at an example now. If there's no question about these 2 things, actually 3 things, right? Left equal to right equal to point, continuous from the left, continuous from the right. Okay, these 2 concepts. Then we'll look at an example. Okay, so that will be the kind of question we'll be doing for homework. So let's look at 21. Okay, so over here we have a piecewise function. Okay, so we want to figure this out without drawing the graph. Okay, and the only way to do that is to figure out the limits and apply the concept that we learned just before, right? So determine where the function is discontinuous and also find out its type. Okay, so we also need to check, okay, is it continuous from left, from the right? Is it a jump? Is it an infinite, right? Is it removable? Okay, so those are the things we want to figure out. Right, so let's start with this one. So the possible places that we need to check is where the pieces are glued together, right? The pieces are split up, not glued together. So if you look at the first function, first piece, it only exists on x less than 0, right? You look at the domain. This part is called the domain. So you have one piece that's on the left side of 0, right? One piece is at 0, and then another piece is at greater than 0, right? And then at that another piece is at 2, right? X equal to 2. So the problem place, right? The suspicious place is at 0 and 2. That's how you pick, okay? And then you just need to check near the limits around those two places, okay? And then we'll find out the type. So let's start with the 0 first. So at x equal to 0. So we have three things to find, okay? One is limit x approaching 0 from the left, and then limit x approaching 0 from the right, and then the point. Okay, left limit, right limit, and the point. We want to see if they equal each other or not. All right, so I'll let you figure this out by yourself. Don't do the 2 yet, okay? We'll do the 2 later. So once you get the answer for these 3, please raise your hand. Remember, you have to choose the piece, okay? Depending on approaching from the left or right side, you pick different piece. Does anyone have trouble like doing this? Because this limit thing is a few classes ago, okay? If you have forgotten how to do it, let me know, okay? I can help you through the steps. Remember to raise your hand if you finished. Okay, let's start with Jesse. Okay, can you tell me for coming from the left, which piece did you pick?
Coming from the left, I picked 3x minus 1 because it's x less than 0.
Yep, okay, so 3x minus 1. So the answer is?
I got -1.
-1, okay. Leon, for the right limit, which piece did you pick?
I picked the -3x plus 1.
Okay, and what do you get?
Just 1.
Yeah, okay. Now for f of 0, Lex, what do you have?
F of 0 is -1.
Yeah, okay, so that one will be a single point. So by looking at the result, right, we have a -1 and a -1 here. but then the other one is a 1, right? They don't equal each other. If they don't equal each other, means it's discontinuous, right? So we can first thing, that's our first conclusion, right? We can say left, determine where the, okay, so we can just say f of x discontinuous at x equals 0, right? Because left limit, right limit, and the point, they don't all equal each other. Now, next part, we need to figure out the type. Do you think this one is a jump, removable, or infinite? Or you can do it by elimination, right? Which one is the impossible? Which one is for sure? Not the type.
Infinite?
Yeah, there's no infinity, right? If you want to get infinite, there has to be infinity sign. Okay, so it will be either removable or jump. Which one would it be?
A jump?
Okay, how do you know it's a jump?
Because there's like, if you graph it out, the two, it's like separated. It's not all like kind of together. It's two separate kind of graphs.
Yeah. Okay, so if we don't want to graph, okay, let's think about how we can tell without the graph. The one that is removable, right? Look at the previous page. Removable is the one at -1. Then the only condition, right? That's not, you will still have limit exist. Left equal to the right side, right? I'm talking about this place. But then at the point, it will be undefined or equal to something else. So the condition is you have limit exist, okay? So if the limit doesn't exist, then it's not removable already, right? And if you have a jump, then the limit will not equal each other, right? For example, the one we did on the right side here, right? Left limit is 1, right limit is -1. Limit doesn't equal each other means one goes higher, one goes lower. Then that's called jump. Okay, so you just check left and right limit, either they equal each other or not. Okay, so we can write that down because left doesn't equal to right, so therefore it's a jump. Okay, now is it continuous? Okay, from the left from the, okay, there's no e. Continuous from the left or continuous from the right? Carrie, what do you think?
On the left,
From the left side, how do you know?
because negative, approaching, like the limit from the left is -1. It matches with the point.
Yeah, okay, so I'm highlighting with a yellow highlight, right? So -1, -1, they equal, and the -1 is coming from the left. Left limit equals to the point, so therefore it's continuous from the left. Okay, so the three answers, okay, three answers that we want to figure it out. So now I would like you to try question, like the second point, right? The second place we want to check is x equal to 2. Okay, so please try this one as well. Once you finish, you can raise your hand. So we can figure out all the answer, right? Try to do this without drawing any graph, okay? Just by understanding the limit, okay? What information the limit can tell you. Otherwise, you will be doing more work than other people, right? So make sure you connect limits with the answer. Approaching 2 from the left. Okay, let's approaching 2 from the right. F of 2. Please raise your hand if you finished. Anyone has questions? Or got stuck? Joan, Leon, Nicole, any questions? Are you almost done?
Yeah, I'm still figuring it out. I'm not too sure, but I think I have stuff. But I'm
I
still
can't find where it's discontinuous at.
Okay, you mean discontinuous from something?
Yeah.
Okay. If you think it's not from any place, then you just say not continuous, right? Or you can just leave it blank. Okay, let's check the limits and the point, okay? Joan, can you tell me your left limit? Which piece did you pick?
I picked the negative 3x plus 1,
Okay, and what do you get?
negative 5.
-5. Yeah, I agree. Okay. And Leon, how about from the right side? Which piece?
Same one.
Same one. Okay. -3x plus 1. So it will also be -5, is it?
Yeah.
Yeah, okay. Now, what about f of 2? Nicole, what's f of 2?
I got 5.
5, yeah, okay, it's the last piece. Right, so we have 3 things. Do they all equal each other, Emily?
Only the 2 limits.
Yeah, okay, so since left equal to right, but it doesn't equal to the point, so you would say f of x is what, Emily?
It is discontinuous.
Yep, very good, okay. Discontinuous at x equal to 2. Okay, so in your homework, they will ask where is it discontinuous? So you have to check, right, by finding the limits. If they all equal, right, then you just get continuous, okay, continuous at that point. Now, what kind of, like, which type of discontinuity is this one? Lex?
At first I thought it was jump, and then I saw that your notes was like, if for jump, it's like L doesn't equal to R, right?
Yeah.
So then it should be a break. I mean, removable. Yes.
Removable, okay. Yeah. You created a new name. That's a good name. Removable. Okay. So yeah, this one is a removable because think of the graph, okay? One from the left side goes to -5, right? And then from the right side also goes to -5, but then at 2, it jumped, not really a jump, it has a point on the top, right? So I can make this become continuous by taking this point and then make it fill this in, right? You are only missing a little dot. When that happens, we call that removable. You are able to remove the discontinuous, okay? So we can say because the left equals to the right, right? Left limit equal to the right, but it doesn't equal to the point. Doesn't equal to f of 2, okay? When that happens, we call that removable. Okay, so is this one continuous from left or right side? Carrie?
No.
So nothing.
Yeah, nothing.
Yeah, okay, so this one is, it because it's completely empty there, right? So it will be continuous from neither side, okay? Neither. Okay, so that will be the conclusion. Okay, another thing that they could be asking is, if it's removable, how do I remove it? Okay, so I can remove, let's add that in, okay? Remove by defining f of 2 to equal to what? What should we redefine? Instead of f of 2 equal to 5, what should I say? Then it will become continuous. Joan?
Wait, sorry, could you repeat that? You were kind of cutting out.
Okay, so because f of 2 is 5, that's why it's not continuous, right?
Right.
Okay, if I want to make it continuous, what should we set the f of 2 equal to?
-5.
Yeah, okay, so sometimes they will ask you this kind of question. Okay, what will be the new function you define so to make it removable, to remove the discontinuity, right? So I think that's enough, okay? That's all the new things for today. For question 22, just a little bit, okay? Can you tell me which points we need to check for number 22? What are the possible places? Lex?
X equals, oh, my bad.
Oh, sure. Jesse?
Oh,
Where?
X equals to 2
2?
and X equals to 1.
Yeah.
Yeah.
Any more?
Oh yeah, I guess X equals to 0 because sine X is a little more unpredictable, or when you look at it.
As long as it happens on the domain, those are the possible place to be discontinuous.
Oh wait, 0, 1, and 2 is all of them.
Okay.
Yeah.
Check all the connecting points, right? You want to make sure do they connect nicely to each other, right? Because piecewise, right? Sometimes they are broken, sometimes they are connected. Okay, so you'll be checking these ones and then do the rest of them. Okay, we'll continue question 22 next week. Okay, so in the homework you will get something similar to 21, and of course you will also have some asymptote questions too. Okay, if you have questions you can stay after, otherwise I'll see you on when? Monday? Yeah. Okay, see you on Monday.
Thank
Okay.
you.
Yeah.
Thank you,
Thank you,
Jason.
Jason.
Bye.
You're welcome. Bye
Thank
bye.
you.
Have a good weekend.